differentiation is, by definitions, successive means following one another or following others. Alright, if you still don't know what the hell is this, alright, if you got watched Naruto, or if you haven't watched or never watched before, never mind, I'll just introduce you to Naruto. So what is it? Naruto, is it linked to math? Is that successive means that, in fact, this is the first Hokage by the name, this hand sign, first, second, third, and fourth, and fifth. So this second person succeeded from the first person. So he succeeded his Hokage name. Hokage is some hero of the town for some reason, or some leader of the town. So he succeeded from the first Hokage, the leader. And then the third lead, this is the third generation of the leader that succeed from the second generation of the leader. And then this fourth generation of the leader succeed from the third generation of the leader. As you can see, each of them succeed from the previous one. So this is the first one, and then successively this second one came out, successively third one came out, successively fourth one came out, and so on and so forth. I hope this is a pretty clear example of a successive definitions of successive. Alright, so what is successive differentiation then? For example, we have a function f. Okay, I don't know why this thing stuck over here, but anyway, imagine we have a function f is equals to x plus etc. So if I were to partial differentiate, if you don't know what the hell is partial differentiation, please watch back the partial differentiation video, or I recommend you click this link. Okay, never mind. If you haven't, you are still on here, then if you don't know what I'm talking later, then good luck. So if I were to partial x itself, I would have this one will become 1 plus y plus yz. Now if I were to differentiate this dude over here in terms of y, what I would have, it's we can rewrite this as partial 2, this partial square f, partial x, partial y. So as you can see, partial y is like, successively behind partial x. You get what I mean? And therefore, if you were to differentiate, you will have 1 plus z. Then if I were to differentiate again, I will have partial cube f, partial x, partial y, partial z is equals to 1. Right? So I think I have fairly made it a pretty much clear intuition to you. So by definition, successive is just this thing. First you differentiate in terms of x, successively you differentiate in terms of y, successively you differentiate in terms of z, while the function is differentiated 3 times, as you can see, right? So this can be also linked to the second order, if you remember, or if it doesn't ring any bell because you feel that it's not cool, you can also talk about second order or third order differentiation. For example, partial f, partial x, partial partial square f, partial x square, partial cube f, partial x cube, and partial n f, partial x n. This trend, right? So this can be also this form, alright? So you are keep differentiating and differentiating until happy and happy and happy. But anyway, this is somewhat the definitions of successive differentiation. If you want to go into very in-depth of how it is being defined or things like that, I seriously don't know where to find. And but in terms of examinations, I think that this is fairly helpful. And therefore, to do up my questions, allow me to share with you. Show that the function of v in terms of x, y, z is equals where it is equals to, so show that v, a function containing x, y, z is equals to 1 over z exponential, etc. So I don't know what the hell am I talking but okay, this thing is the question. It's like a function. It's just the thing that is, in other words, v is equals to this one. That's all it's saying, okay? And therefore show that this function satisfies this equation. So you're gonna prove, right? Same as the partial differentiation of the chain rule and not chain rule but rather partial differentiation itself. So it's very similar, and you're gonna just prove it. So in order to prove it, what I would suggest is that I've pasted the function here so that it's easier for me to actually click or do whatever shit I want. So now I'm gonna elaborate on this thing. Right? So I'm gonna differentiate 2 times in terms of x and differentiate 2 times in terms of y, and shows that it is equals to when I differentiate the function in terms of z. Alright? So the first step first I need to do is to differentiate in terms of x. Alright? So if I were to do that, I think we just do it together with you. Normally when you have this thing over here, right at the top, you just differentiate the inner one. So in terms of x, right, so I can just rewrite this simply as minus x squared over 4z plus y squared over 4z. This is totally the same thing as what is over here. I'm just splitting it up into the fraction of it, right? And therefore in terms of x squared, in terms of x, this means that this whole thing is equals to 0. I'm gonna don't care about it anymore. So this is the benefit of splitting things into 2 parts. Alright, but you can only split the numerator, don't split the denominator. Alright? And therefore if I were to differentiate, I would have 2x minus 2x over 4z. This is the exponential term. And then if I were to differentiate and multiply it into the thing, if you don't know what I'm doing right now, you can go and search for exponential differentiation. Alright, you should have a fair bit amount of I think I just recommend videos. Hold on. If I type in exponential differentiation, I would have the first one, Mr. Patrick. So you can just click him and just check it out. It's just a 5-minute video. I think it's fairly cool. Otherwise you can just search it out. Whichever the case that helps, it helps. Alright, so yeah, and therefore where am I? So if I were differentiate down, I just bring this term down to here, right? If you know why I'm talking, okay, if you're in the same channel as me, right? So 1 over z e minus x squared plus y squared 4z. So this whole thing that I've just written it down, it's equals to partial v partial x. So I'm gonna differentiate again. Okay, I'm gonna differentiate again because they want to prove that partial square v divided by partial x squared is this is the thing that they want you to do, right? So you're gonna differentiate 2 times. So what I've differentiated is only 1 time, so I need to differentiate another time. And therefore if I were to differentiate another time, because I know that differentiating the exponential term over here yields us this term, right? And therefore I just multiplied it in. This equals to minus 2x 4z squared 1 over z e minus x squared plus y squared 4 over 4 z. Yeah. And no, it's wrong. You know why is it wrong? If you are smart enough, or if you are cool enough, not smart rather than if you are vigilant enough, this is an x which is in front of another exponential in terms of another term's x. So if this is x and it's in front of another term with having an x, you're gonna use product rule, right? When you're gonna use product rule, you're not talking about dealing with that. So please be careful that don't do what I have done. I know that I have carelessly done that, but since I've done wrong, why not I share with you? So I differentiate this term first, and then I keep this term, and then simply said I let this term I set it equals to a. Okay, simply said I set this term as equals to a, some arbitrary variable, because I want to just write things in simple ways. So assume that I treat this as a, okay? So assume that I treat this as a, notwithstanding that I threw it away, just that, So I would differentiate this term first. I would have minus 2 4z, right? So I'm just differentiating x away only. Dot 1z, 1 over z, alright? This term still stays. I mean, this term still, whatever. So now I stay this term, so this is a which is this term, right? This is equals to a. So I put it over here. Now, product rule states that I differentiate this term, I keep this term, then I differentiate this term, I keep this term. If you still remember, if you don't remember, good luck. Anyway, so if I differentiate this term, okay, this term will always be the same, so I just put it as a first, alright, and then we know that after differentiating the exponential term, what I would left with is this term. This is what we have did just now. So I'm just differentiating this, and I will get this term over here. That is all what I'm talking about, right? So I'll just simply write it down over here for z, right? And then dot with, which will have kept this term staying the same. So I have minus 2x 4z 1z. Okay, and then now I rearrange. Okay, I just put things in terms, like make it neater, so that at least it is easier for you to see. Plus minus 2x times minus 2 times this one, I would have 4x squared over 16z. It is 1z, 2z, and 3z, so I have z cubed over here now, right? A, where a is, which is what we have defined earlier, this one. Okay, this is, I mean, not this one, this term, right? So this is the second order partial differentiation of the v in terms of x. Now in terms of y, you know that x squared and y squared, the differentiation method is somewhat the same, so I'll not go through this, alright, because due to certain time constraints, and it's really kind of boring if you like, but the method is the same. You eventually get, okay, let's say I just write it down. If you're free, you just write it, you just do it yourself. Otherwise, so in terms of partial differentiation 2 times of the y, right, it's somewhat the same method as what we have. So I'm just simply writing my answer down, so at least you can refer to it if you are free and you want to do it. Just try it out, you'll be happy a little while, happy, sexy. Anyway, so you have partial v and partial y already, so I've cleared away this term and this term. So now I'm gonna do this term and then prove that adding up these two terms will give you this term. Alright, this is what the question wants you to do. Okay, so the reason why I want to partial v partial z is because I want to show you the product rule also, right? So partial v partial z is equals to, so as you can see, there is a variable over here now. There's a variable in front of another variable z. So we're now in terms of, sorry, my yellow color thing, I don't know what the hell is going on with it, but yeah. Anyway, so the z is in front of another same z. As you can see, this is the form of a product rule. You need to really identify. When you see this type of thing, you're gonna use product rule really. Definitely 下午睡. Yeah, anyway, I don't know what I'm talking, but yeah. So I keep this term, I differentiate this term, I keep this term. If I differentiate 1 over z, I have minus 1 over z squared. How do I do this? 1 over z is equals to z minus 1, if I differentiate, I have minus 1 times z minus 2, right? So it's equals to 1 over z squared. This z minus 2 is equals to 1 over z squared, simply said. Alright, so if you don't know what the hell I'm talking, repeat that. Just click back a few seconds ago. You can just hear what I'm gonna repeat. So you know that this term, I know that this is just a, so I just write it as a for simplicity's sake. Alright, and then so because I differentiate this term, I keep this term. Now I'm gonna differentiate this term, I keep this term. Okay, so if that's the case, then I keep 1 over z. Now I differentiate in terms of z. Alright, previously we differentiate in terms of x, then after that I redifferentiate in terms of y, which I didn't show you. Now I differentiate in terms of z. Okay, so if I differentiate in terms of z, then what I would have is I need to use, okay, no need, x squared plus, I bring this 4z, you know, 4, I bring it up over here as minus 1, right? And then I differentiate. When I differentiate, I bring this minus 1 over here, I have plus 1, x squared plus y squared. I differentiate the inner one, so I would have 4. Sorry, I just keep it like that first, okay? So I differentiate, I minus 1, and then I differentiate the inner one, which in the end I result in 4. And therefore, this term, if I were to rewrite, I would have x squared plus y squared 4, right? So the 4 is just a constant in front, and then 4z squared. Alright, so because it's minus 2 over here, alright, and therefore what the hell am I doing? Z squared, and then I'll just clear this up a little bit. I bring this over here. Yeah. What the fuck? I bring this over here. Sorry. Yes. Wouldn't it be nice? And then don't forget the a, because a is, when you differentiate any exponential, the terms over here will always stay that. It will always stays here. Okay, it will not change at all. So therefore we have this thing. Alright, so now we're gonna sum them up together. So just let me write out. Okay, after which we're gonna elaborate this in order to prove that it's equals to this one, which is what the question wants us to do, right? Show that this term is equals to this term. I mean equals to, you know, satisfy this phenomenon. Alright, so okay, where should I start? Alright, and okay, I'll just thicken my brush so that it's at least easier for you to see. So this term and this term, if you add together, you would have this term. Right, if you add them together, you have this term. So simply said, minus 2 over 4, which is equals to minus half, right? So this is what I'm talking about over here. So minus half z squared plus minus half z squared, right? Where a is outside now, because they're the same thing. Therefore, minus half plus minus half is 1. Sorry, this should be, the z squared should be at the denominator, okay? So yeah, 1 over z squared. So you get what I mean? So in fact, I think you get what I mean. So simply said is taking this term plus this term, you have this term over here. That is what I mean and what I'm doing just now. Okay, it's quite straightforward. If you don't understand, you just write on the paper and you know what I mean already. It's just simply that half plus half is equals to 1. 1 over denominator is z squared, so it's z squared. And then 4x squared plus this term will give you this term. Okay, simply I multiply this z into here, I have z cubed, right? Correct, so this term will go, So 4z cubed is the same as their own denominator if I were to change this to 1/4, if I were to simplify them. Okay, if I were to simplify them, then 1/4 plus 1/4, I have 2/4. Okay, I have careless mistake. Paiseh, sorry. Okay. Okay. Anyway, so this term it is not 4z. It's like that. Okay. So if I were to square this term will become 16z squared, right? And therefore, if I were to multiply in z, I have 16z cubed. So be very careful when you're writing stuff, because I myself also sometimes kill myself. So it's all square, alright? It's the whole thing square. Be very careful about that. But nonetheless, this term plus this term will give you this term. Will give you this term. That's the intuition about it. Alright, so therefore, this is it. This is the answer. Although I didn't explicitly prove for you that this whole chunk is equals to this one, but if you do it up, it should be the same. Alright, so let's say this is 16. If I multiply this everything in, I'll have 16z cubed. Alright, now wouldn't it be clearer now? 4x squared plus 4y squared is this one, and then below is 16z cubed. Yeah. As for this term, it's just simply this thing plus this thing. Okay, you have 1 over z squared a, where a is equals to the exponential term that I have previously said. Alright, so this is it, and this is the successive differentiation. Next video we'll talk about total differential, so which is a little different, and I'll see you there.